If you're setting up a workstation to connect to the network, it's going to need a configuration that includes IPv4. This is the most popular networking protocol in use today, so it's important that you know all of the different configuration options for IPv4. There's also a newer IP protocol appearing, IPv6 or IPv6. This protocol is included with many modern operating systems, so it's also important you know how to configure IPv6 as well. Here's an IPv4 address. It's 192.168.1.131. And IPv4 will always follow the same format of 4 separate numbers separated with a period between each one of them. As you can see in this binary representation, this is 32 bits long, or 4 different bytes long, and each byte separated with that period. Since you have 8 bits to work with, the number that can appear in each one of these sections of an IPv4 address is a number ranging between 0 and 255. Because each one of these octets in an IPv4 address are 8 bits long, the values that you would see in each one of these sections is a number between 0 and 255. IPv6 addresses are much bigger than the 32-bit addresses from IPv4. IPv6 are 128-bit addresses, which means we can have a very large number of available addresses with IPv6. This means of the 6.8 billion people on Earth, we could begin assigning IPv6 addresses, and each person could have this many IPv6 addresses for each individual. IPv6 addresses look very different than IPv4. You can see that they are separated into 8 different sections, and each one of those is a 16-bit or 2-byte section. Instead of using periods or dots to separate the addresses as we do with IPv4, in IPv6 we use a colon, and the IPv6 address is represented in hexadecimal rather than in decimal. So you can see FE80 0000 0000 5D18 0652 CFFD 8F52. And that is one entire IPv6 address. Fortunately, there are ways to abbreviate these IPv6 addresses. If they're leading zeros, such as 0652, you can simply state that as 652 as an abbreviation. If there are consecutive sections of this address that have zeros, we can remove all of those zeros and replace them with a double colon. This means it will become more difficult to memorize an IPv6 address, so we'll need to rely on our DNS servers so that we can refer to these devices by name rather than IP address. If we look at most IPv6 configurations, the first half or the first 64 bits of the address are generally referred to as the network prefix, and then the last 64 bits of the address are the node or the network address of the device. If you're troubleshooting IPv4 or you're making configuration changes to IPv4 on someone's workstation, there are a number of settings you'll need to check. The first is the IP address. Every device needs a unique IP address. You don't want to have duplicate IP addresses on the network, and usually if you do assign a duplicate IP address, the operating system will warn you that another device on your subnet shares that same IP address. The second piece of information you'll need to configure is the subnet mask. An example subnet mask is one like 255.255.255.0. This is a value that's used by the local device to determine what IP subnet it happens to be on. The subnet mask is usually something you configure on the local workstation. It's not a value that's generally transmitted across the network. And if you're someone who's configuring an IP address on a device, it's very common to ask at the same time for both the IP address and the subnet mask for a workstation. The third piece of information you'll need to configure is a default gateway. This is the IP address of a router that's on your local subnet. If you don't configure a default gateway, your workstation won't be able to communicate outside of its local network, and it certainly won't be able to communicate to the internet. Another piece of information that's almost mandatory to configure on someone's workstation is a domain name server IP address. When we type the name of a website in our browser, we don't use IP addresses. We use the name of that site. We type in professormesser.com or google.com, and we have no idea what the IP address of that device might be. But of course, your routers and all of the routers in between you and that web server need to know the IP address of those devices. That means there needs to be a translation between the name of the device and the IP address of the device. And to make that translation, we use a DNS server or domain name system server. If you look at the DNS configuration for your operating system, there's usually at least 2 slots available to put DNS IP addresses, and very often there's even more than that. For example, on my device, I have 2 IPv4 DNS servers listed, 8.8.8.8, which is the DNS server at Google. Google also has a second DNS server available at 8.8.4.4. And you can see I have IPv6 addresses available for IPv6 DNS resolution. We list multiple DNS servers in our configuration in case one of those servers becomes unavailable or we're not able to communicate to that device. That way we have at least a backup system that we can use to continue to perform this name resolution.